A blade server is a stripped-down server computer with a modular design optimized to minimize the use of physical space and energy. Whereas a standard rack-mount server can function with a power cord and network cable, blade servers have many components removed to save space, minimize power consumption and other considerations, while still having all the functional components to be considered a computer. A blade enclosure, which can hold multiple blade servers, provides services such as power, cooling, networking, various interconnects and management. Together, blades and the blade enclosure form a blade system. Different blade providers have differing principles regarding what to include in the blade itself, and in the blade system altogether. In a standard server rack configuration, one rack unit or one-way 19 inches wide and 1.75 inches tall defines the minimum possible size of any equipment. The principal benefit and justification of blade computing relates to lifting this restriction so as to reduce size requirements. The most common computer rack form factor is 42U high, which limits the number of discrete computer devices directly mountable in a rack to 42 components. Blades do not have this limitation. As of 2014, densities of up to 180 servers per blade system are achievable with blade systems. Blade enclosure performs many of the non-core computing services found in most computers. Non-blade systems typically use bulky, hot and space-inefficient components, and may duplicate these across many computers that may or may not perform at capacity. By locating these services in one place and sharing them between the blade computers, the overall utilization becomes higher. The specifics of which services are provided may vary by vendor. Power. Computers operate over a range of DC voltages, but utilities deliver power as AC, and at higher voltages than required within computers. Converting this current requires one or more power supply units. To ensure that the failure of one power source does not affect the operation of the computer, even entry-level servers may have redundant power supplies, again adding to the bulk and heat output of the design. The blade enclosure's power supply provides a single power source for all blades within the enclosure. This single power source may come as a power supply in the enclosure or as a dedicated separate PSU supplying DC to multiple enclosures. This setup reduces the number of PSUs required to provide a resilient power supply. The popularity of blade servers, and their own appetite for power, has led to an increase in the number of rack-mountable uninterruptible power supply units, including units targeted specifically towards blade servers. Cooling. During operation, electrical and mechanical components produce heat, which a system must dissipate to ensure the proper functioning of its components. Most blade enclosures, like most computing systems, remove heat by using fans. A frequently underestimated problem when designing high-performance computer systems involves the conflict between the amount of heat a system generates and the ability of its fans to remove the heat. The blade's shared power and cooling means that it does not generate as much heat as traditional servers. Newer blade enclosures feature variable speed fans and control logic, or even liquid cooling systems that adjust to meet the system's cooling requirements. At the same time, the increased density of blade server configurations can still result in higher overall demands for cooling with racks populated at over 50% full. This is especially true with early generation blades. In absolute terms, a fully populated rack of blade servers is likely to require more cooling capacity than a fully populated rack of standard one-use servers. This is because one can fit up to 128 blade servers in the same rack that will only hold 42 one-U rack mount servers. Networking. Blade servers generally include integrated or optional network interface controllers for Ethernet or host adapters for fiber channel storage systems or converged network adapter to combine storage and data via one fiber channel over Ethernet interface. In many blades at least one interface is embedded on the motherboard and extra interfaces can be added using mezzanine cards. A blade enclosure can provide individual external ports to which each network interface on a blade will connect. Alternatively, a blade enclosure can aggregate network interfaces into interconnect devices built into the blade enclosure or in networking blades. Storage. While computers typically use hard disks to store operating systems, applications and data, these are not necessarily required locally. Many storage connection methods are readily moved outside the server, though not all are used in enterprise-level installations. Implementing these connection interfaces within the computer presents similar challenges to the networking interfaces, and similarly these can be removed from the blade and presented individually or aggregated either on the chassis or through other blades. The ability to boot the blade from a storage area network allows for an entirely disk-free blade, an example of which implementation is the Intel modular server system. Other blades, since blade enclosures provide a standard method for delivering basic services to computer devices, other types of devices can also utilize blade enclosures. Blades providing switching, routing, storage, SAN and fiber channel access can slot into the enclosure to provide these services to all members of the enclosure. Systems administrators can use storage blades where a requirement exists for additional local storage. Users, blade servers function well for specific purposes such as web hosting, virtualization, and cluster computing. Individual blades are typically hot swappable. As users deal with larger and more diverse workloads, they add more processing power, memory and I/O bandwidth to blade servers. Although blade server technology in theory allows for open, cross-vendor solutions, the stage of development of the technology as of 2009 is such that users encounter fewer problems when using blades, racks and blade management tools from the same vendor. Eventual standardization of the technology might result in more choices for consumers. As of 2009, increasing numbers of third-party software vendors have started to enter this growing field. Blade servers do not, however, provide the answer to every computing problem. One can view them as a form of productized server farm that borrows from mainframe packaging, cooling, and power supply technology. Very large computing tasks may still require server farms of blade servers, and because of blade servers' high power density, can suffer even more acutely from the heating, ventilation, and air conditioning problems that affect large conventional server farms. History: developers first placed complete microcomputers on cards and packaged them in standard 19-inch racks in the 1970s soon after the introduction of 8-bit microprocessors. This architecture operated in the industrial process control industry as an alternative to mini-computer control systems. Early models stored programs in EPROM and were limited to a single function with a small real-time executive. The VMEBUS architecture defined a computer interface which included implementation of a board-level computer installed in a chassis backplane with multiple slots for pluggable boards to provide I/O, memory, or additional computing. The PCI Industrial Computer Manufacturers Group PICMG developed a chassis blade structure for the then emerging peripheral component interconnect bus PCI, which is called compact PCI. Common among these chassis-based computers was the fact that the entire chassis was a single system. While a chassis might include multiple computing elements to provide the desired level of performance and redundancy, there was always one board in charge, one master board coordinating the operation of the entire system. PICMG expanded the compact PCI specification with the use of standard Ethernet connectivity between boards across the backplane. The PICMG 2.16 compact PCI packet switching backplane specification was adopted in September 2001. This provided the first open architecture for a multi-server chassis. PICMG followed with the larger and more feature-rich advanced TCA specification targeting the telecom industry's need for a high availability and dense computing platform with extended product life. While advanced TCA system and boards typically sell for higher prices than blade servers, advanced TCA suppliers claim that low operating expenses and total cost of ownership can make advanced TCA-based solutions a cost-effective alternative for many building blocks of the next-generation telecom network. The first commercialized blade server architecture was invented by Christopher Hype and David Kirkby, and their patent was assigned to Houston-based RLX Technologies. RLX, which consisted of mostly former Compaq Computer Corporation employees, including Hype and Kirkby, shipped its first commercial blade server in 2001 and was acquired by Hewlett-Packard in 2005. In February 2006, Blade.org was established to increase the number of Blade platform solutions available for customers and to accelerate the process of bringing them to market. It is a collaborative organization and developer community focused on accelerating the development and adoption of IBM Blade server platforms. It is no longer available. The name Blade Server appeared when a card included the processor, memory, I/O and non-volatile program storage. This allowed manufacturers to package a complete server, with its operating system and applications, on a single card/board/blade. These blades could then operate independently within a common chassis, doing the work of multiple separate server boxes more efficiently. In addition to the most obvious benefit of this packaging, additional efficiency benefits have become clear in power, cooling, management, and networking due to the pooling or sharing of common infrastructure to support the entire chassis, rather than providing each of these on a per-server box basis. The research firm IDC identified the major players in the Blade market as HP, IBM, Dell, and Cisco. Other companies selling Blade servers include Avaya Direct, Oracle, Agenra, Supermicro, Hitachi, Fujitsu, Rackable, Scale and Intel. Blade models. Though many independent professional computer manufacturers such as Supermicro offer Blade solutions, the Blade server market continues to be dominated by large public IT companies such as Cisco, which achieved number one position on the Blade server market with 40% share by revenue in Americas in the first quarter of 2014. The rest prominent brands on a Blade server markets are HP, Dell and IBM, though the latter sold its x86 business to Lenovo in 2014. Cisco offers a unified computing system in its Blade server portfolio. A domain, consisted of 6 U-high chassis, up to 8 Blade servers in each chassis, up to 20 chassis in a domain, all managed by a heavily modified Nexus 5K switch, rebranded as a Fabric Interconnect, which converge computing and networking, and manages the whole system as a single entity. HP's current line consists of 2 chassis models, the C3000 which holds up to 8 half-height ProLiant line blades, and the C7000 which holds up to 16 half-height ProLiant blades. Dell's latest solution, the M1000E is a 10U modular enclosure and holds up to 16 half-height PowerEdge blade servers or 32 quarter-height blades. See also, Server Computer, Blade PC, Multibus, References. External links, Blade Center Blade servers are Euro x86 processor-based servers, UCS Blade servers are Euro Intel registered trademark Xeona registered trademark processor-based servers.